Good afternoon, everyone. So, as mentioned, we will be having a hopefully friendly debate about the two main technologies to ensure trustable computation on the blockchain domain. So, these two domains will be the TE, or Trusted Execution Environments, and the Zero-Knowledge Protocols. So, I would like to start with a bit of an antagonistic question. We are living now in a post-Snowden world, so trusting hardware manufacturers and hardware companies is sometimes a bit hard. ZK systems are very sound from a mathematical perspective, but sometimes being sure that they prove what they're actually supposed to prove may be a bit hard and a bit arcane. So how would you say that you are convincing your users to trust you on your system?
Do we want to start with TEs? Okay, sure. So, well, if you think about it, like, yes, in terms of TEs, we actually might have to kind of like place trust to the manufacturers of the TEs, but there are kind of like several factors to kind of like mitigate it away from this. So one of it is that how is it, the kind of like the threat actor, be it a state or like several states, they can't actually target a specific person. So in terms of TE as a technology, if they would want to kind of like build a backdoor in there, there would be a backdoor for everyone, which includes actually the state actors themselves. So it's like opening your own backdoors such that you can have a potential ability to compromise your target. So that's one. The second one is actually, we do not need to, so TE in itself is actually not a monolithic kind of thing. We don't need to rely on one single manufacturer. There are a lot of different manufacturers. There's like Intel, there's AMD, there's, what's it called? IBM, there's ARM. We even have like RISC-V based TEs. For example, like if you are not like US inclined, there are companies, for example, Alibaba, Huawei, they are all developing their own RISC-V chips, and some of them actually have TEs built into them. So the third one really is something that I'm really excited about, is that why do we need to rely on all these traditional manufacturers, right? We can have an open source hardware movement. There have been calls to kind of like build a totally open, trustless hardware, trustless in quotes. There's still a certain level of trust that's needed, but like with everything that is open, with kind of like decentralized techniques that is baked into some of the manufacturing process or even the testing process, we can actually improve the kind of like reliability, robustness, and trustworthiness of the hardware that we are using. So yeah.
Yeah, I think of the responsibility we have to users of our technology as giving them the ability to verify some things offline so that they can verify some things online. So in the case of TEs, it's the sort of hardware supply chain, the trust in a manufacturer. In the case of ZK, it would be any sort of trusted setups, the idea that the circuits that are being proven actually correspond to the programs that the users care about getting verified. And when I think about evaluating what's important for a user, I think what we need to do is to package the set of things that a user needs to pay attention to into as few small touch points as possible. Yeah, and the reason for that is fundamentally the users of this technology, if it's to really grow and be successful, are not going to be technically sophisticated, either on the hardware or the cryptography or the software side. So the point is, no matter what is being used, we need to make it very clear and easy for users to ultimately understand what are the assumptions, do they agree with them, and sort of how can they check them if they want to go deeper. And so to some extent, they are delegating their trust to some more expert people who have checked. And so I do think it's a bit of a spectrum in terms of all of the trust assumptions and whether it's okay for different use cases.
Thank you. So now I would like to go back a bit to my engineering roots. And we all know that every single product that comes out on the market is made of compromises, right? You never have the perfect trifecta or pentafecta or tetrafecta or whatever. So I was wondering, both in your own ways, how do you find an equilibrium point in your product between performances, safety, and convenience for your users? Why did you choose this point of equilibrium, and how did you manage that from both a business and a technical perspective?
Yeah, I think on the ZK side, what's important is to maintain clear abstractions between the parts of your system that might move fast and are security critical, but maybe are very important for performance, and the interfaces, which ideally are not security critical, but make a lot of difference for your user experience. And so at Axiom, we've been building a ZK VM called OpenVM, and that actually helps a lot because we can work on improving the ZK VM underlying performance, and it gives a very good interface between us and our users who work on using the VM, and we can improve the SDK for them without having security risk and danger for their funds. And so we in general think of ZK as offering a very good abstraction layer between different types of cryptography, and we think when we're designing the system, choosing those interfaces is actually the most important thing to allow the progress to happen in parallel across different layers.
So, I mean, why I kind of like chose to work on TEs? Well, the thing about TEs is that it actually kind of resides in a very interesting equilibrium, so-called equilibrium point, where you actually have relative good performance. It's relatively cheap to operate. It's relatively abundant. That means access to all this like trusted execution environment hardware is easily accessible, and you can actually get relatively good guarantees on certain on the integrity and confidentiality of your code and data that is being computed on within the trusted execution environment itself. Now, of course, there's no free lunch. There's going to be some trade-offs here. Like one of the trade-offs would be actually like the kind of like inherent trust assumption on the hardware manufacturers, the actual parties that manufacture the hardware itself. But in my mind, I think that this is a relatively kind of like good trade-off or like acceptable trade-off. And why do I say so? Because, I mean, if we think about, I mean, like exploits aside, like there have been a lot of talks about how like TEs are frequently exploited. There are vulnerabilities and things like that. But like, there's one thing that I want to make a point, which is all code is written by humans, and humans typically write bugs instead of like code. The code is just a nice side effect of us writing bugs. So this kind of vulnerabilities will exist in all kinds of systems, and what we have to do is really like how can we actually manage it? How can we compose all the different solutions to make it a more robust solution? So, like kind of like to circle back, the reason why I kind of like chose TEs really is it provides this very nice balance of performance guarantees and ease of access. And of course, there are certain kind of like properties that a TE can provide that ZK systems can't, or like other cryptographic systems can't. And that it's a kind of like very nice general tool that you can use to solve problems.
Thank you. I would like to bounce on something that you both alluded to, which is that technically all of these systems are written by humans, right? So even if the system were to be perfect, we cannot expect the people implementing the system to actually be flawless. So I know that, for instance, I mean, if we take an example, ZK circuits, they don't prove what you want them to prove, they prove what you tell them to prove, right? I assume that's exactly the same for the people designing the hardware and so on and so on. So I know, for instance, that there are some efforts on the ZK domain to push formal verification method for circuits. I guess that you have the equivalent in hardware design for TEs. How do you see the field of this kind of meta verification of system in your two domains? On what are the, let's say, the path that seems the more promising to you?
So like one of the kind of like usage of like TEs like is actually to kind of like work in tandem with ZK proof system. So like one of the collaborations that we have is actually with Scroll. So Scroll is a ZK EVM, right? A ZK rollup. Instead of relying solely on just like the ZK validity proofs as that only one single proof system, your entire system will actually be made more robust if you have an alternate implementation in a trusted execution environment. So you have the ZK proof system to provide the kind of like that trust anchor that people would like. It's heavy, it's thick, the anchor itself is thick, it's trustworthy, but it's expensive, relatively speaking. But the thing is, if you want to add another ZK system to it, it's going to be really heavy in terms of like the cost of running the infrastructure and the proofs and things like that. In this case, why not introduce like trusted execution environments into the mix where the TEE can provide a cheap, relatively robust method to kind of like check and make sure that both systems are actually doing fine. So the converse can also be said, like if you have a TE system that maybe is like optimistic in a sense, that is like sending attestations or assertions about certain computation, you can actually use a ZK proof system to kind of like maybe once every day or once every 6 hours to kind of like provide a trust anchor to kind of like say that, hey, you know, up to this point, everything is fine. So yeah.
Yeah, just maybe to respond to the point about having T as a backup for ZK or vice versa, I do think it depends a little bit on your application. I think we maybe all agree that the threat model for base layer Ethereum is some sort of state level attack. And there you do have to be pretty paranoid. Like, yeah, I don't know if some state wants to compromise the TE, but you know, this is sort of the design space. I think when you think about a rollup, there is a real sort of product level question of is the rollup designing for that level of attack? I think if not, then certainly TE is pretty robust to non-state actors, I would say. Maybe someone in a garage is fiddling with the TE, but I think I think this links to one thing, which is I do think TEs have a weaker abstraction boundary of what the assumptions are. Like there's some sort of vague, like you need $100,000 to break the hardware, but no one really knows, or maybe you need some very sophisticated entity to break it, but it's not clear. Whereas I think the advantage of ZK is that there are ways mathematically to try to prove that what you're implementing actually corresponds to the algorithms. And maybe to go back to the question, we think that it's not necessarily, oh, you hit it with formal verification and now you're done. Like we did some early research work on formal verification for ZK circuits. We do believe it's possible to, with enough brute force, just formally verify everything. And in the long run, we think you can formally verify while developing. But we think that there are a lot of things outside of the realm of formal verification where a human, and many humans ideally, need to be auditing whether the algorithm is truly getting some level of cryptographic security. And I think it's not possible to really get away from that.
I like that optimism about formal verification. so I do kind of like work with formal verification. I'm a little bit less optimistic about it, but yeah.
Just to give a sense, we worked with a group that was able to formally verify circuits for ECDSA verification.
Yeah. Yes, but like actually a lot of formal verification techniques actually require some level of modeling and abstraction. So what you are kind of like verifying is not the actual truth, but rather is a projected kind of like idea or image of the...
Yeah, who is verifying the verification, right?
Yeah.
Yeah, totally. And I think for something like a rollup, what you would want to verify is that your circuit matches the node level rollup STF. So at least, yeah, it's definitely not the ideal STF, but it is the STF run in practice.
Thank you. So now I would bifurcate a little bit and go to another topic, which is, let's say, the availability to users. Both methods require specific hardware, be it quite powerful CPUs on, let's say, generous amount of memory for the ZK stuff. For the TEs, of course, you need to have access to the ISA extensions or to the hardware or coprocessor extensions that will ensure they're working. Are you afraid that these requirements will create some kind of aristocratic caste within your users that are those that can actually run the algorithms? Or do you think that the evolution both in conceptualization of the systems and availability of the hardware will make it available to the largest numbers of users?
Yeah, I think for ZK today, if you want to be at the cutting edge of performance, you do need fundamentally a server. But I think we're experiencing a pretty exponential decay in the amount of compute you need. And maybe last year, you maybe needed a big server on AWS, maybe several big servers. Now it's in the realm where you might have a home server, like an advanced user might have a home server with one nice GPU, and that's enough. And I actually see that in maybe end of year or next year, it'll be possible to take a relatively more ordinary desktop, and maybe you're not going to be at the same latency or cost as the optimized cloud service, but you'll be able to do something. And I think that transition will actually change the types of applications that we can build, precisely because of this removal of the resource barrier and concurrently the type of trust assumption you can make on proof generation.
Yeah, as for TEs, I'll kind of like want to maybe correct a little bit of misconception. A lot of people think about TE and they immediately kind of like, their kind of like mind would switch towards things like Intel SGX, Intel TDX, this sort of like hardware-based trusted execution environment. But at its core, a trusted execution environment is just an isolated environment. So if I have a mechanism to isolate my computation and my compute environment, then this compute environment can be, and I'm able to kind of like assert or attest to this environment, then this environment can be considered a trusted execution environment. So with that kind of like out of the way, right? Like that, the accessibility of TEs has been like improving year after year. I mean, initially we only have ARM Trust Zone, then we have Intel SGX, now we have TDX and AMD EPYC servers. Actually, I would want to make that claim. Every single one of you here, every one of us here, actually we have a TEE and it's in our pocket. Our phones have a TEE. If you have an Apple phone, you have a secure enclave that is actually running on your phone itself. And then if you have an Android phone, then most likely you actually have the corresponding like trust zone implementation of that specific manufacturer that you have. So moving forward, the availability of TEs would get more and more, and this would kind of like, this allows everyone to actually participate in a protocol or in participating in some like service, because like people might not have $1 million lying around, but they might have a TEE lying around somewhere. So yeah.
Okay. Unfortunately, we are starting to run out of time, so I would like to finish with a quick question, one for each of you. So for you, regarding that side channel attacks are a bitch, how do you picture the future of, let's say, vulnerabilities, fixes and correction in the TE world?
So with regards to like vulnerabilities, it's gonna happen. And we actually have like 30 years on how we deal with like exploits and vulnerabilities. Like we have the entire SecOps around it. So the question is, how can we actually do it in a transparent manner, in a decentralized manner? And that is why I like the idea, and we have been pushing very hard on this idea for putting the kind of like attestation collaterals, the kind of like infrastructure for verifying all this hardware on chain. You have a decentralized chain, you have consensus, we can verify the thing on chain. If something happened, we don't have to wait for the manufacturer like Intel to say that, hey, like we are going to blacklist this or something like that. We can immediately do it on our end. Like the community can decide what is acceptable and what is not acceptable. So yeah. And as for like kind of like the side channel attacks, we have been like, this has to do with the kind of like some of the properties that a TE have. So a TE, in my opinion, a TE is good for storing short-term secrets, ephemeral secrets, and less so for storing long-term secrets. So for side channels, if you are kind of like doing it for short-term secrets, actually the most
greatly reduces
exactly
the fast attack.
yes
Yeah, that makes sense. Thank you. And for you, for the ZK world, we know that the ZK are backed by very serious and very solid cryptographic mathematics. But what do you think about all of the ancillaries that may, let's say, weaken the whole system? So typically the signing ceremonies, and do people actually verify the proofs that are published, and so on? So all these weaknesses that may reside around the system, if not in the system itself.
Yeah, it's a great question, and I think that it's probably something our industry doesn't emphasize enough. I view it very similarly to something like smart contract verification. Obviously, if Etherscan doesn't provide this as a utility, probably very few dApps would go to the trouble of actually doing the verification, showing it to their users, and there wouldn't be a trusted source to delegate your verification to as an ordinary user. Today in ZK, there isn't really a similar service. I think some teams take the trusted setup pretty seriously, others take it much less seriously, and right now the policing is roughly by the community. I think there's challenges to that. Many parts of the community are competing with each other, so it's definitely less credible if you're criticizing your direct competitor. So I do think there's room for a more neutral arbiter to provide both a technologically enabled solution, but also a less potential criticism or compliments that are not biased or subject to aspersions.
Well, unfortunately, we're out of time. Gentlemen, it has been a pleasure talking with you. And well, I guess that we'll see in a couple of years what come out of this field that I hope to be very, very fruitful in any case. Thank you.
Round of applause for our
Thank you.
panelist.